let's get started. We're going to pull this out. First thing we're going to do is take the keyboards out and do some maintenance, preventative maintenance on those. We're going to pretend like we just got this organ and we have just taken out the analog and we're now ready to install a brand new system. So we're going to treat it like the organ hasn't been played in 20 years. And we're going to go ahead and there are some things you need to know when you get into a project like this that will avoid problems later, such as examining the key contacts and the shorting rail and making sure it's clean and testing the keys so that we don't have any stuttering or anything like that. So we'll get into all that as we take it apart. So here we are. We've been gutting the instrument for the past week, and we're going to do this in a modular sequence. We have some. Basically, we're rebuilding the whole instrument all over again. We have our speaker arrays loosened, ready to come out. Now, there's only so much room to work in here, so we're doing one step at a time. We left the pipes in because, quite frankly, that's the safest place for them. We do need to open up the chest and fix one valve. So that's the first thing I'm going to do. Now, a little bit about planning. It looks like there's a huge amount of space in here, but when we're all done, there's not going to be any room for anything. We're going to put our pipe drivers on this wall, our power distribution center, which I made yesterday, on this wall, and our Artisan micro MIDI system on a relay panel here. And the purpose for that, instead of screwing it directly here where it was, is I need to remove this panel to get to this blower to oil it once every 6 months or so. So we have deinstalled everything. We have our pipe chest cables here, our right side draw knob jam cables here, our manuals, and they are already connected to the micro MIDI system, and they're wrapped with anti-static bubble wrap to protect them because we are going to pull the keyboard out and do some maintenance on that as well. And our pedal input board. 12 volt for lights, and the left side draw knob jam. And we also have the 3 key switches from the left jam, and these cables will be replaced with these newer, nicely labeled cables. In planning on a system like this, where we have a lot of audio going on as well, we need to sort of map out where we're going to run cables and keep everything separated. In this installation, we're going to keep all high voltage and low DC voltage towards the pedal board switch array, and keep our audio signal and amplifier lines on the back side of the organ to keep things separated so we don't pick up any interference. The other thing we're going to do is build in a shelf here, and we're going to put our PC in here. I really didn't want to butcher up the console by adding card readers and USB ports and everything. So the interim solution until I get a dedicated machine is to lay it on its side in here so I can access the front of the machine by pulling the top of the draw knob off, which just lifts right up. For now, that's our solution for that. And when we upgrade, the shelf will be here for the new machine, and it'll just sit there. Now on the speaker arrays, they're pulled out because we used to have the PC surround system on top of the organ, and now it's going to go inside. So I need to be able to drill out for that and add those speakers. Our power amplifier is not going to be located in here anymore to ward off again any interference. we're going to put it in the left-hand speaker tower and run all of our signals and everything through there. What else do we have that needs to be addressed? I think that's about it. So what we're going to do, I'm not going to let this roll while we do everything because we end up with a 16-hour video. I'm going to open this chest and fix our valve, and then we're going to mount our power supply. The reason this is so large is because we have the key switches that, if you've been following anything we've been doing over the past few months, you'll remember I have a key switch for the 12-volt power supply, which is here, and that feeds our Artisan keying and our pipe drivers. Then we have the second key is for our amplifier, because if you remember, I don't always use the large amplifier. I sometimes use the smaller system. And then the last switch is for our blower. And in each one of these boxes is, these three anyway, is a Dayton solid state relay. It accepts 3 to 32 volts in, and it closes the AC line to allow to turn on things. And our dedicated 15 amp circuit goes inside this box and always powers these 4 outlets. This transformer that's here goes up to this terminal strip, and it's supplying 12 volts so that when we close our key switch contacts for each relay, that's where it's getting its power from to power the relays. And that's about it on that, and we'll see you in a few minutes. Now, I promised an organ crawl as well as installation of the Artisan keying system in combination action. I had to open this to adjust a valve and inspect everything else. I haven't had any other problems than just one note. But I thought you might like to see what the inside of this chest is. For those who don't know, each one of these blue coils is a Reisner magnet. And of course the pallet opens when energized to allow air to go through. And that's what our chest cables are for coming out. Let's look at the Schwimmer. This is the wind regulator for this instrument. It's what we call a Schwimmer, actually. And we have springs on here that regulate the wind pressure. We're set at, I think it's just a hair under 2 inches or a hair over 2 inches. And it expands as it fills with air, and the valve closes off when it's got enough air, and opens up to let air back in. So what we've done now is we've installed our power strip, or power system. We've put our blower back in place and connected that. And we've run our 12-volt lines over to where the power is needed on this side for the pipe drivers. In planning, we need to design things by, in this case, how much cable we have. The pipe drivers, we have plenty of cable, and that's just going to be fine over here. Our keyboards have a lot of cable, but our pedal board does not, so we need to keep it in this general vicinity where it used to be. And then the biggest limitation are the stops from the left side draw knob jam. We need to make sure that our micro MIDI subsystem for the stop controls goes towards the top of this. So what we're going to do is we're going to cut out a relay panel for our pipe driver system and mount that here, and then we'll pick out one of these other 2 relay panels sitting here to see which has the best fit for here, and we'll lay out all the Artisan hardware. So let me go ahead and cut this panel. Well, it's been a couple of hours since our last filming. I want to bring up a couple of points. Regarding our power distribution center, we are not live here yet, and we won't be until we're all finished. Notice that this is our incoming power, and it's blocked off. It's just a safety in case somebody goes and flips the breaker accidentally. To test everything individually, we unplug each item, like the blower. I tested this earlier, and plug it into an extension cord or something else. The other thing, I think when we left earlier, we were about ready to mount our pipe driver relay, which is finished, and I'll bring the camera over here to show you. So our 12-volt mains come in at the bottom of the driver relay, and we're going to tap off of this to feed the Artisan system as well. This is our flute rank and our principal rank, both 49 notes each. We're not driving anything very heavy here, so we are sharing our power from board to board, with the exception of the motherboard. I gave that its own power supply. These are regular Molex, not Molex, phone jack connections that speak between, and a serial cable to start off the connection. This driver is for remote activation of the power relays, of which I only use one. It's for the clock feature. If you remember, I have some MIDI files programmed to activate an output here, which turns on the blower over there. We have one cable remaining for our lamps, and there's another main on the chest at the other end for a safety, and I've written myself a note that I need to fuse this when it comes time to connect it. We didn't connect it yet because I'm going to share this with the leads that come over here to the Artisan system. Now the next step is going to be to put in our shelf for our computer, and I'm going to measure and cut for that and get everything ready to install, but we're not going to install it yet because it'll make putting the Artisan system in a little bit difficult. So the next time we come back, we're going to actually pull the keyboards out and get into cleaning and prepping them for permanent install. Now, when we left last time, I was going to build a shelf for the computer, which we did do, and we tried the computer, and we were 3/4 of an inch too large to put the back on the console, so we have changed our mind, and we're going to put the computer on the base of the organ, and we have cut out our name board above the keyboards to accept the Alesis QSR, and a power button for our computer, LED and power light, and also a USB and card reader, which you'll see later. It has been refinished and it's drying now. So we've taken our relay panel out of the organ. Our keyboards are up here. They're also drying. We've been applying a light coat of Minwax to them to bring the finish back a little bit and clean them up, and we've gone through and cleaned any contacts we needed to take care of in that area. What we're looking at here are all the components that are going to be mounted on this board, and I'll go through them and what they are. We're missing one, which is the pedal, but that's sitting down there because we have a cable length issue as far as filming is concerned. So the components are fairly simple. I'm going to break them up into the two systems that are going to be mounted here. The first is the keying system, and what we have is a UMIDI Artisan microcomputer, and each one of these is assigned a particular task. It has MIDI in and out. There is another version of this available that has multiple MIDI outs, up to 4 I believe. This one we don't need that many, so we have our in and our out. And what we're doing, the other part of that system is each input board called an HV64, and this board is actually for the Great Manual, and this one is for the swell. And I'm actually working on lacing these up now. I haven't finished yet. I'm waiting to see how far I need to go. What I'm doing here is trying to figure out where my components are going to go. So that would be system number 1. System 2 is another UMIDI microcomputer, and its function is going to be to light our draw knobs when jOrgan tells them to, because that's the application I'm using here. Now this microcomputer could be controlled, could be programmed for a full-blown combination system, but I'm choosing not to do that just because I don't need that. We have 2 stop jams. We have a total of 42 draw knobs. Each one of these accepts inputs here from the draw knobs and outputs to the lamps for the draw knobs. Ours do not move, they light up, and these are special boards just for that. And there's one for the left and one for the right draw knob jam. Now, as I mentioned earlier, planning is very important. You really need to know the lengths of the cables that you have that are going on a board, and where your components need to lay. I've already tested our cable from our furthest draw knob jam, and really this is the only place that this board can go. We have plenty of length from the other draw knob jam, and so what I'm going to do is put our 2 driver boards here. I want to fuse it, and I'm going to put the fuse, I'm not sure yet. Our 2 microcomputers can go here. And our input boards for our keying somewhere around here. Our pedal is going to go here. Now on these boards I haven't brought my main over for the keyboards yet. There are several ways to connect these boards. There's a jumper here for positive or negative. In my application I don't have to worry about that because we're not applying any voltage whatsoever to the keyboards. It's taking voltage directly from the communication line, the modular phone connection from the CPU to each board, which is 5 volts. And in that regard, we don't have to worry about what the polarity is because it's basically a closed loop system. However, if you were to, let's say, add this system to a Rodgers that you're keeping all the original guts to, you know, in other words, if the racks were still in here that were original, and we're just adding MIDI capability and not gutting the entire instrument, then we need to be concerned about what voltage the original builder's using, and excuse me, what the polarity of the main is coming in. Then we do need to be concerned about that, and also where to. Now in this case, the main just goes to this jumper, and that's where it ends. In some cases, though, this jumper has to go to negative or positive of the power supply, depending. But of course, the people at Artisan will make you aware of that fact when you order their system. This is our 5-volt power supply, which is going to supply the logic voltage for these 2 microcomputers, and We also need to tap off the 12-volt rectifier to feed our lamps on these two boards. So now when laying these out, I like to be very neat. I want to get my first board in, and to do that, I had a drill bit here somewhere. Here it is. It's important to use the right size screws on these. When you're going to a hardware store, these are actually number 4s. And you want to try them before you do anything and make sure they go in and move freely. You don't want them to bind up on the mounting posts. Now we need access to this screw hole for mounting. And I'm simply going to pilot one we go very slowly. Tentative. We're not tightening these down yet. We drill our second hole. We want to have our drill bit extended as far as possible so we don't mess up the board. Steady while we drill the last 2 holes. I'm sorry for the quality of the video and the space that we have to work with, but you do what you can do, you know. Clean it off and clean off the relay panel. And you can also use an awl to mark your holes with and then cut them. I would recommend that rather than what I'm doing, but I'm used to doing this so much that I feel comfortable doing this. And I'm just putting 2 screws in for now. And I like to use a spacer to keep everything the same. I want to leave 2 inches here. This is a 2-inch spacer. I want to leave 2 inches because we have a rather large bundle of cable coming through here. can, when you get to this point, it's better to just drill a small pilot. Make sure we're still lined up. Move our board and go ahead and drill these through. So what we're going to do is continue mounting. I'm not going to film the whole thing. Once I get these boards mounted and these two keying boards mounted, I'll start filming again, and we'll go into a little bit about lacing and making our cables neat, and by then we should be able to put this back into the organ along with the keyboards, and then after that we're going to take our draw knobs out, which are out already, but we're going to lay them out here and go through tracing. I was lucky with these cables, taking them off the Rodgers, being the same color, that I kept them in the same order. You're not always that lucky, and I'll show you what I mean when we go to the draw knobs, which are also all the same color, and we're going to have to trace each and every lamp out, and also the sensing for the on-off. So we'll be back in a couple of hours since we laid out our boards. Just for a reminder, recap, this is UMIDI control board for our keying system, and again we're missing our pedal board, which will attach once this goes into the organ. Our second UMIDI on top is for our stop action draw knob lights for input output. This is for the left side jam, this is for the right side jam, and this is our power supply. Now this isn't quite as neat as I would like it, but we had some extra cable in the keyboard stack. However, we were a little bit shy on our piston inputs, which go to the pedal board, so we kind of had to double up over here. When we do our draw knobs, it'll be much cleaner because we'll cut our wires to fit, whereas this was already previously done except for the lacing, and I didn't want to go through and butcher up all the wiring. So what we have here are our mains from our keyboards, our common, our key inputs, and again, as I discussed before, we're not worried about polarity, but please do keep in mind that this exists in your application. You may need to know this. Over here on our keying input, we also have input for our swell shoe, which is on input 1, and what I'm doing is duplicating the input on input 2, and I'm going to switch that through software to make the swell shoe either an actual swell shoe or a crescendo shoe, whatever I want. We have the common for the pot, which is a 10K pot, and the plus 5 volts, and the wiper goes to these inputs here. We have our power going in for our logic, plus and minus 5 volts coming from the power supply. And we've left 2 pigtails. This pigtail is one and the same. It's for the single toe stud we have at the moment, but I'm using 6 pair wire because I want spares in case I ever decide to add toe studs. And then we have another pigtail attached to the power cord for the swell shoe. So why don't we go ahead and put the keyboards back in place and mount the relay panel, get our pedal input board mounted and connected, and then we'll start on our draw knobs. So what we have here is our lamp driver board from Artisan, accepting inputs from the draw knobs and then outputs to light the indicators on the draw knobs. And we have our draw knob jam here, and what I'm doing is tracing out. We have figured out that our main is the brown wire and that our switch inputs are the smaller browns and the greens, and our lamps are the yellows. We have a meter with an audible signal and a clip lead that is shorting the main to each wire, and we're tracing each wire as we go along and placing them, the inputs where they belong. And then later we'll put a 9-volt battery to actually light up the indicators to find out who's who. So let me reposition the camera here, and I have 2 draw knobs left to do. We'll take care of those and then we'll get into the lights. Now on these boards we have 32 inputs. We have 18 draw knobs on this jam, and what I'm doing, these draw knobs are pull on and push off, but because I'm going to employ touchscreen monitors later for other uses, I'm going to get used to pushing each draw knob for on-off. So we're tying the on-off senses together into one input. And we have 2 left. My clip lead is on the brown wire first. So my meter is connected to ground for that switch. And then I have a probe. I'm trying to find which of these last 2 brown wires is the next draw knob. And this is the one. So we wrap that here for now. We move our clip lead to the green wire on the draw knob. And that's not it. This is the one. So now we have both of our wires. And I'm using this shim, you see, because there are no mounting posts on the card. They physically couldn't do it because of a double-side printed card. So when you're doing this, it's a good idea to put a shim underneath so that your pressure doesn't bend the card. And my next input is number 17. So measure and cut. last two are obviously the last draw knob, but we're not going to assume, because there are spares in the cable. So we just want to double check and make sure that really is the last draw knob. Yes. Move our clip to the green wire. Yes. And I'm doing two pairs at a time in my lacing. So I want to match number 17. And we will lace those up. I'm giving 2 twists. Now our next cable is going to come in here, which is for the lamps. So we can go ahead and neaten up the cables from here back by lacing them up to that point. And it looks a little bit messy, but it gets neat as you pull things tight. And by the way, this gray cable in here is added because we have 2 potentiometers on the face of the draw knob jam that used to control the intensity of the draw knob lights, and there was a tuning control. And I want provisions for both, and the cables are very short. Those wires are up in this area, so we added a cable into the trunk so that we can still have that functionality later. The lamp control will not be used as a lamp control. It will be for something else like Zimbel's turn speed or something like that. And this final one, 2 loops. So I want it real tight. Now, our signal wires are finished. That's all the draw knobs we have on this jam. We have 2 cards because we had too many draw knobs to make it on 1 card. We had a total of 42 here. So we're finished with the clip lead on that main. Now the blue wire is the main for the actual lights. And what we're going to do with that, and we're done with our meter so we can get rid of that. We're actually going to turn the draw knob jam around so we can see our lights. And turn off this light. Now, as I stated earlier, the yellow wires are our lamps for each draw knob. And I've separated them into groups of 4 because we have 4 rows here. And our blue wire is the main for those lamps. And what we want to do is find out which group is number 1. So we have a clip lead to a 9-volt battery and the other side of the main to the other side of the 9-volt battery. And we see that we have in our hands row number 1. So we'll set these aside. And on my sense inputs, I have already gone ahead and done this from left to right. So we want to find our first indicator. And we have that here in our hands. Pull it taut. This is our cable. Double check. And we brought our lacing to point number 1. We want to move our shim. Give a slight tug to make sure it's tight. Number 2. Make sure we have the right one. And we will lace these two because I'm working on the even numbers, groups of 2. Because the spacing is so tight, you really can't do every single one of them. I did that on the other board and it kind of came out messy. I'm in no way an expert at lacing, as you can see. But it facilitates in trying to figure out where a certain problem is. You can see how neat this would be as opposed to just everything just hanging out there. And we continue in turn. This is number 3. Double check. This is obviously number 4, but we want to double check. Group of 2 and we lace again. And we keep going until they're all populated. So here we are a few minutes later, and we have taken our cable away from the mounting, cutting off the old cable ties that held it to the mount. And I like to tape the end of my connections even with the board, or as close as I can get anyway. We'll go ahead and mount this board and continue on. So I wanted to take this last little video here before we close this up, just to recap what we're doing here. All the background noise that you hear on the video is actually, everything's powered up. The computer, the blower, and the amplifier in the tower here. Everything's running. Everything's been programmed and tested. It works great. You can see what this looks like all lit up. It's waiting for commands is what it's doing. It's searching for, it thinks we're ready to play. So let me just turn this on and recap what we've done here. Now remember, we started with our UMIDI system number 1. There are 2 complete systems here. This one is for the keying, our brake keys, our swell keys, and our pedal board and pistons. And then we added our combination system, thank you Artisan, and our 2 special lamp drivers. They are for the draw knobs. Our inputs from the switching are here, and our lamp outputs are here. And that really completes the entire console. So draw knobs, keying, toe studs, pistons, and lamp driving. Now, if you had SAMs, stop action magnets, or tablets, or draw knobs that move, these would be replaced by keying, pretty much keying inputs and another type of driver capable of handling that load that you need to actually move things with. So there's a wide variety of equipment available from Artisan to accomplish really anything you need to do. And then on the chamber side, your pipe chamber side, and it doesn't have to be real pipes, it could be anything, it could be just a sound engine in a cabinet or whatever. You know, I'm using Syndyne because I had it already, and we have that of course mounted on the side, and you saw that before. So what else have we done? What else is in here? The computer system running jOrgan, Halpork, MyOrgan, you know, any of the software that's similar, is accepting MIDI input from the Artisan system, and the Artisan system is listening for a reply if there's any needed from the computer. That's USB device number 1, and that is sitting on top of our audio subsystem. I'll get to that in a second. So this is for the Artisan system. This is strictly isolated from everything else. On the output side, trying to keep it separate, it's hard because this is all one instrument, but in a pipe chamber, we have a separate MIDI communication device, USB again, and we have two outputs on this. One goes to a tone generator, or this is an Elisa's QSR, which we mounted in the name board, and the second channel goes out to our pipe controller. This next bundle of cables is communication to the PC itself. We actually took out parts of the PC and mounted them in the name board to include a card reader and a USB port so that we could communicate with the computer without having to touch the computer or have access to it. There's also a power button, which is a piston, a power LED, and a hard drive activity LED, so I could see, you know, that we're not really locked up, we're actually doing something, we're actually processing something on hard drive or something. Then from there, we have our two audio subsystems. The first is Logitech 5.1 system. This is the subwoofer and amplifier unit, and the rest of the speakers are split up into towers, and then there is one center channel on this side of the pipe chamber. There's another identical center channel on this side of the pipe chamber, but it's hooked up to the power amp. So what we did was the original speaker outs from this amplifier we put on the terminal strip. And here the speakers go to the original speakers that were with this system. Then we tapped off here and went to the tower amplifier, which powers the original router speakers, of which we've replaced 4 of them, and the new center channel, which didn't exist before, which is over here. Now, why did we add an amplifier? It's because this system wasn't quite powerful enough to match the pipe work without pushing it too far. And if you're an audiophile, you really don't want to push your audio system to the limit. There needs to be some overhead. So what we did was added some overhead just to match the pipe work. We're not trying to blast out everybody. We're just trying to come up to the level and match. And it really turns out very nicely when everything's in place and all the controls are set right and everything's in balance. I don't think there's anything else to go over here. What we're going to do is button this all up now and move it back into place, and we're going to go over installing the Artisan definition file for these two systems, which the definition looks at it as one complete system, and you add, of course, what you need according to your specifications. So we'll close this up and we'll be back in a few to go over that. So here we are in the final leg of our rebuild. I just want to show you real quick here, we added the wireless receiver for the mouse and keyboard. This is the card reader that we added with a USB port, an SD card reader, and our power button for our computer system, power light, and hard drive indicator, and our Elisa's sound unit, sound module. And over here we added a slim DVD writer so we can do other projects as well. So right now everything's running except for jOrgan. jOrgan's not running right now because I wanted to demonstrate the combination system here. as you can see, we have the system up and running. One of the important things with the Artisan system, you need a map switch or piston. I'm just temporarily using a piston, but you can put it on a switch hidden inside the console or something. And what that's for is to set up your associations, like your generals. Let's just take a look here. Now, general piston, everything is going to be associated with that on this organ. And you can see all the draw knobs are lit. That means that any of the lit draw knobs can be assigned to that particular piston. Now, I don't have anything set on these two floaters, but let's just say they were pedal division. I would want to light up all of the stops that I want on my on that divisional, and I would hold my map and my set and commit it. Now if I want to check that it held, it did. Now on this piston, we're pretending that this is a swell divisional piston, so I want to take a look at what is assigned to that piston. And all my swell stops are assigned. Now if we had a Tootie, we would do the same thing. Usually you don't want tremulants and 16-foot couplers on a sforzando, and that's how you block those stops from being assigned. So now what we want to do is go ahead and this is a programmer's file editor. The file you're looking at is the actual definition file for the Artisan system, and it's unique to every single instrument. What we have here, this is the first, those small 4x4 cards, the brains, U-MIDI modules. This is the very first one in the chain, which is going to which defines our keying system. So the first line is the addressing the actual module, and because they're connected in order, there's no numbering scheme. It shows U-MIDI module, the first one in the definition file is the first one it hits, and then the next, and so on. So we have two. The first one, these first three lines are expression and tuning pot. The second line is commented out. The first one is our swell shoe, and the second one, third one is our tuning pot. Then we have the definition for the great keyboard, the swell keyboard, and the pedal key contacts. And below that, we've used the extra contacts on the board for our 14 pistons, and those are set here. Now they're not in order by name because we didn't ring out all the pistons because there are so few of them. We just put them anywhere on the board, and we used the MIDI monitor afterwards to actually go ahead and ring them out. But this is the actual order they are on in the board. So like General 2 is actually the first input, and we are telling it, we're calling the piston General 2 because that's physically what it is. It's plugged into terminal number 40 on the driver card. It's going to respond to MIDI channel 15, and the note number we want it to send on channel 15 is number 1. Now further down is the second MIDI module, and that's for lighted stops. And this is a very, very simple program because we're not hard coding any sounds here or pipes. We're letting jOrgan do all that. So all we simply need to do is tell it that we have two lighted stop drivers, and we're going to control them on channel 12, starting with note number 1. And then finally down here we have our combination action, which is internal, and that's why I didn't start jOrgan right now, because I wanted to demonstrate that jOrgan is really not controlling these lights. It's all within those 7 boards on that little relay, and all the memory and everything is in those boards. And you can see it is responding without having, I don't have anything set apparently on 3 and 4. We can go ahead and set something there, and we'll add these. That's better. Back to this, on the combination action, you need to define your set piston and the map piston. And like I said, that map is very important because if you don't have it, you can go ahead and try to set combinations and they may not hold because the system doesn't know what you're allowing it to commit to a certain piston. And then we have just our pistons listed, and then that's it, we're finished. Now, this program, this editor that we're in is the recommended editor for these config files. Do not try to open it in Notepad or WordPad or Microsoft Word or anything like that, because it will potentially corrupt this file and you'll have a heck of a time trying to load it into the system. Now, we're finished with this. But you know what, we'll leave it open, but we'll just minimize it. This is the actual UMIDI config loader. It's actually a combination of things. It's just an interface to communicate with the boards themselves. Mostly used for programming and monitoring. And what we would do is, we've already chosen where our file is and what our USB device is that we're working on. I'm just going to download it. It only takes a minute or so. Now we see that it finished successfully. If there are any errors, it will tell you what line the error is on and what the error is. Enter to get out of there. Now, going back to this, remember I said that these pistons in the input side were not in order, and you can very easily go and figure out where you have actually plugged in your devices to. So we go into monitor, and it opens the MIDI device so that we can actually see everything work, such as I can go ahead and hit the Gedect flute, and it's showing that it's on channel 12. It's draw knob number 51, which is correct because that is the second board. Actually, draw knob number 1 is over here. I believe this is the first one. Yes, it is. And that's on the right jam, which is the first input board on our relay. And it shows off, okay, and this is off. Now I want to find out where piston number 1 is, so I have it in the right spot in the config file. And it is showing me that it's number 4. And so I can go back to my config file, and general 1 is indeed number 4. test all of our pistons for function. And if you wanted to, you could check your keys. If something goes on weird that you maybe wired your keys, you swap two wires or something and you have something going on, you can easily find out just by looking at this here. So we Control C to get out of this. We're finished here, so we can exit. We're done with our config file. Now we want to go into jOrgan. How do we how do we associate the draw knobs to jOrgan? We simply go into Customize. It's a little slow because of the screen capture software. Now, I've already done this earlier. I set the whole disposition up. Let's take the mixture, for example, or let's take the octave 2 actually. And all you really need to do is, now we have the, again here, USB audio device like we did with the Yamaha and the Axiom keyboard in the jOrgan series of videos. You have to specify your console device. And we want an activate message. And a deactivate message. And we're finished. So the octave 2. Whoops. And we can see that works. I have some dirty contacts, but they'll wear themselves in as it gets used. That hasn't been used in a number of years. Now our pistons, I went ahead and did some pistons earlier. And it's up to you how you know, every organ is different. And one second, let me close this. Actually, let me stop the screen capture because we're finished with that. So now that the screen capture is closed, we can see. Everything is pretty quick here. And the draw knobs don't match up to what's here because this was just a quick demonstration. I assigned a few, and you know, it's up to the user to go ahead and you know, on a large organ like Paul Stratman's American Classic organ, I would be using the draw knobs to control the pipes within jOrgan. I still have my pipe division here, but the draw knobs would be used, the lit ones anyway, for that. Now this organ I use a lot for practicing, and I will go ahead and match up. I would probably make them permanent and match the draw knobs to the actual jams on the screen. And actually, now that this is in, the combination action is in, there's really no need for a monitor or a mouse or a keyboard. I could theoretically, if I wasn't involved in so many things, take the monitor away and the keyboard and mouse and configure jOrgan to start when the computer comes up, and have now Artisan control everything. So let's cancel. And so I hope the video wasn't too long for you, and that you learned something here. If you have any questions, or if there's something you think I missed, you know, my email is on my website, and of course the good people at Artisan would be happy to answer any questions. And in the realm of virtual organs and real hardware, there's so many options. There are so many different ways we could have done this. Some people prefer to have jOrgan control the draw knobs and not, you know, like some people want to build a full-blown. They have one disposition they like, and that's their instrument, and they want to get enough draw knobs to do that. You can drive these with pipe drivers, so that was an option. But we like the combination action being within the Artisan system because it's much quicker, and not to put jOrgan down or help work or anybody. It's just the sound rendering portion of the program, which jOrgan doesn't do, but what I'm trying to get at is the less functions in the software, the better. So if the hardware can do the job, and quickly, it's less taxing on the computer system that you're getting your sounds from, and the software that's relaying to that, it's less for that software to think about, and the sound quality is a little bit better. You know, for instance, if you're playing and hit a piston, if jOrgan has to think about that piston change and react to it in the middle of a chord, you know, it's not all that advantageous to use it that way. If we can have the Artisan system do the processing for us, it's quicker, and it doesn't interfere with our sound rendering engine. So anyway, we're finished here with this project, and in the next few weeks we'll start explaining how we got the pipes to work in jOrgan, and you know, as we go along, other options that Artisan can supply to accomplish some of the same things we're doing. Actually, everything that we're doing in jOrgan can be done with Artisan, but there are different ways people